So this is coding. This is complex numbers in video games. So we can use complex numbers to help represent numbers in video games. The application is actually pretty big because you're able to use it for graphing. Now graphing is a very simple, it's really simple actually. But how this would work is you have your complex number, which you can represent by having a real axis and an imaginary axis. So, and let's say you have the complex number 4 plus 5i. This would be represented on the graph as 4 units over and 5 units up. And so, you would get that point. Now, you would wonder what application you would use this for. How does this relate to programming? Well, we need to rotate a point. How we do this is by multiplying the entire equation by I. So if you multiply your complex number by I, you will actually rotate the entire complex number by 90 degrees. 90 degrees to the left. And so let's take our complex number, let's multiply it by I. Let's multiply it by I, and we take our complex number, we multiply it by I to get 5i to the second power plus 4i. Because I to the second power is -1, we get -5 plus 4i. And then we can represent that on our graph. How we would do this is we would go 5 units over and 4 units up. Well, -5 units over. And boom. It's not loading. And boom, now we have just made a rotation around this point on this axis. And we can keep doing that to get in the entire circle. Now, let's see this in practice. So, rotate around, and the green character we can also rotate, is us. So if I press space, it will rotate us by 90 degrees. Now you see these two numbers up here? This is our x position and our y position. The imaginary number is our y, and the x is the real. So when I press the space bar, we multiply the number by I. And this is actually really easy to code. Let me show you the code. It's actually extremely easy to code because you just take your point, you just swap the two, and then you multiply the real number by imaginary I, by -1 to represent you're multiplying the numbers by an imaginary number. And so this code made without using any turn blocks. This code I was able to create this, which is actually pretty cool. I can even move this point, the rotation point, to anywhere I want, and I can rotate around that, which is actually really cool. And how I did that was I represented the points. I changed the points right here. So this would be able to change basically where you rotate, which I found really cool. Now, you're wondering like, oh, well, this in game design, this doesn't really look, it's neat, but it's not interesting. It's just kind of code. Well, we can be able to make this interesting with a couple of applications. So some uses include we can make a UI. We can make something rotate like a Ferris wheel. If we had like a background Ferris wheel, in the background we could rotate it. That would be pretty cool. Or we could have a button, for instance. We could have a button that kind of like has like a little circle thing around it, and you can be able to rotate it because of I. If you multiply it by like a certain amount of I, you can be able to do that. Or we can create a reflection. So you know how you have like a mirror, and then if you have like a laser pointing at it, and then it bounces off, you could create that in a video game because you would be able to figure out you would be able to change the rotation of it from certain points. So like if you hit it at this angle, and because if you hit it at this angle, you will rotate it up by that many units. Or you could create there's actually this application of complex number in video games has a ton of uses. There's also a bunch of different code variants you can use to make different rotation and axis changes. So that's basic. That's what I really like to use programming complex numbers in video games, because there's actually a lot of different uses for it, like rotation. And to be honest, I actually didn't know any of this, but I think it's neat that you can use this and it actually has a lot of applications for it. Thank you. See ya.